Okay, give 10.2, number 53, a try. All right, when you read through the problem, this is what you should have recorded. The sample size for males is 56. The sample size for females is also 56. The average for the female group is, let me line that up. The average for the male group is 16,569, and the standard deviation for the male group is 9,108. The average for the female group is 16,177, and the standard deviation of 7,520. All right, with that information, we're ready to get going. We're doing a significance test here. We need to start out defining our parameters. It's mean, so it's mu. The true, actually let's start out with m, just to be consistent here, since m was on top here. So this will be the true average number of words spoken per day by male students at this university, really technically. And mu f will be the true average number of words spoken per day by females at this university, female students at this university. So we will use a two-sample t-test. T because it's means rather than z for proportions. Our hypotheses. Looking at the question, we're asking whether there's a significant difference between the two. So that would mean mu m minus mu f differs from, not equal to 0, versus the difference is equal to 0. A totally acceptable alternative, if you wrote it this way instead, is just mu m equals mu f versus alternative mu m not equal to mu f. Either one is fine. It's also fine if you put the female in front before the male mean. That's going to mean that later on, when we get down to the calculations, your t-score will be the opposite, negative of what I have, but the rest of your calculations should be totally the same. The p-value will be the same, the decision is the same, so it won't matter actually which way you do that. Okay, so let's see, where are we? We're on conditions. Random, independent, and normal. They're both random samples. Independent. So here it's the 10% condition because we're sampling without replacement. So 10 times n is 560 for both of our samples, males and females. So a large university would have more than 10 n equals 560 male and female students. So the 10% condition is met. And then finally, normal. For means, you have 3 different ways of checking. Either you're told that the populations are normally distributed, and we don't know that here. It's possible that they're skewed one way or the other, that there are some people who talk a whole lot, and other people who talk almost not at all, or more weighted in one direction or the other. We just don't know. We also can't graph it here. First of all, these are big sample sizes, and we don't have the raw data. But we can use the central limit theorem because the sample sizes are bigger than 30. So both sample sizes are more than 30. 56 each. So the central limit theorem says that the sampling distributions for X bar will be approximately normal. Make sure you have an approximately in there, even if the population distributions are not. And anytime you use the central limit theorem, you should write a brief sentence kind of explaining what it says, just showing that you really understand how to use it. Okay, so conditions are met. Calculations. It's a t-test, so that means we're going to have to calculate a t-statistic. Anytime you use a t procedure, you want to give degrees of freedom also, and a p-value for any test, significance test. So t is, you don't have to write that up there with t, degrees of freedom, and p-value. I just like to remind myself of what I'm doing. We have our sample statistic, so x bar for m minus x bar for f, minus our parameter, so this would be mu m minus mu f, but that whole thing, we're just going to use our null hypothesis value of 0. So that'll disappear. Over the standard deviation squared for m, this big formula, which you can find on the formula sheet for comparing to means. Plugging in what we know from the problem. Those are our sample values. 0 is our null hypothesis value. But rather than crunching that all into my calculator, I'm just going to go to the calculator and choose the 2-sample t-test. Just going back up to show you what I input here. I don't have the raw data. That would be if I had everything in lists. Instead, I'm going to choose 2-sample t-test and choose the statistics entry to enter summary statistics. Here's my male values, x bar, s sub x, sample size, and then female values. So enter your 2 different samples. My alternative is a not equal to, a 2-tailed alternative. Always choose no for pooled. Calculate. Notice it gives me a degrees of freedom along the way here. So my t statistic, just copying down from the calculator, is, oh dear, where did my, okay. My t statistic is 0.2484. Again, if you did female minus male, you would have gotten negative 0.2484. And then, so that's t. Degrees of freedom from the calculator is 106.20 approximately. This is that ugly formula that you saw in the reading. Do not use that ugly formula. I have never used that ugly formula. I dislike it. I let the calculator do it for me, or I use the conservative estimate of smaller sample size minus 1 if I need to do it by hand. And for the p-value, again, you always want to write p-value instead of p. It spit out 0.804, a very high p-value. Okay, so now conclusion. Since the p-value of 0.804 is greater than, we don't even have an alpha, but any alpha value that we would choose would be smaller than that. Remember, 0.1, 0.05 and 0.01 are our most common ones. So I'll just write greater than any reasonable p-value or alpha value. Significance level. And I'll give an example. Alpha equals 0.1, kind of the most conservative, the closest comparison. So because, remember, if P is low, we reject HO, but this time we definitely fail to reject the null hypothesis. So this study is not convincing evidence of a difference between male and female students. Average number of words used per day. Part B asks you to put the p-value, to interpret the p-value. So I thought that was a nice thing to review as well. So remember, the p-value is 0.804. And so what this means is that if the null hypothesis is true, so in context that means if there is no average difference, if there is no difference in the average number of words between males and females, okay, so that's saying if the null hypothesis is true, then remember the p-value is a probability of getting a sample like the one we got as far apart. So the probability of getting samples as far apart or further apart in average number of words as the ones we got is around 80%, 80.4%. So that's a pretty high probability. So that seems to imply that it's not unreasonable to think that there probably is no difference here because our samples are not that unusual in that circumstance.